Section 2.3, the remainder and factor theorems. Example 1, use long division to factor polynomials. We're going to factor this completely using long division if x minus 3 is a factor. So if we're going to do long division, we're going to put x minus 3 on the outside. And then on the inside, we're going to put 6x to the third minus 25x squared plus 18x plus 9. And we're going to make sure that we haven't missed any powers of x. We have 3, 2, 1, 0. We haven't missed any. If we did, we'd have to put a 0 in for that missing power. Now, how many times, what do we have to multiply x times to get x to the third? Well, x squared, but we want, when we multiply, we want this to match. So we're going to have to multiply by 6x squared. Now, 6x squared times x is 6x to the third, and then we just keep multiplying. So then we have minus 18x squared, and with long division we always subtract. So negative 25 minus negative 18 is going to be negative 7x squared, and then let's bring down the next one. Well, now what do we multiply times x to get negative 7x squared? Well, negative 7x. So negative 7 times x is negative 7x squared, and then we multiply negative 7x times negative 3, and we get plus 21 x. Well, in long division, we always subtract. 18 minus 21, that's negative 3x, and then plus 9. Well, what do we multiply times x to get negative 3x? Well, negative 3. So negative 3 times x is negative 3x, and then we have plus 9. And what we find out is we have a remainder of 0, which means x minus 3 is a factor. We were told that. So we expected the remainder to be 0. So now we're going to factor completely, so we know that we have an x minus 3 as a factor, but now we have to factor 6x squared minus 7x minus 3, and that factors into, let's see, we probably could have 3x here and 2x here. How about minus 3 and plus 1? That'll be negative 9 and positive 2. So this is the original, completely factored right there. Long division with non-zero remainder, divide this by 3x plus 2. So we're going to do this with long division. So we'll put 3x plus 2 on the outside. And then we have 9x to the third plus 0x squared, because we're missing an x squared. So we want to represent that x squared with a 0. And then minus x minus 3. Well, what do we multiply times 3x to get 9x to the third? Well, that's 3x squared. So 3x squared times 3x, that gives us the 9x to the third. We always want to make the leading term the same so that when we subtract, that leading term goes away. And now whatever happens here happens. We have 3 times 2. That's going to be plus 6x squared. Let's subtract. 0 minus 6 is negative 6x squared. Let's bring the minus x down. Now, what do we take times 3x to get negative 6x squared? Negative 2x. So we have negative 6x squared, and then we have minus 4x. So minus 4x, and in long division, we always subtract. So negative x minus negative 4, that's 4x. Whoops, that's not 4x. That's going to be, we have negative 1 plus 4, that's negative 3x. Minus 3. So what do we multiply times 3x to get negative 3x? Well, negative 1. We have negative 3x minus 2, and now when we subtract, we get negative 3 plus 2, that's negative 1. So the answer is 3x squared minus 2x minus 1, and then minus 1 over 3x plus 2. So that right there, that's the fractional part of an answer. And that's like saying, well, what if we take 7 divided by 3? 3 goes in there 2 times. That's 6 with a remainder of 1. That'd be 2 plus 1/3, or we just usually write it as 2 1/3. So this is the same format, except we're using variables with this one. Example 3, division by polynomial of degree 2 or higher. We're going to divide this polynomial by x squared minus 2x plus 7. So the x squared minus 2x plus 7, that goes on the outside, and then the other polynomial, this one goes on the inside. 2x to the fourth minus 4x to the third plus 13x squared plus 3x minus 11. And we have 4, 3, 2, 1, 0. There are no missing powers, so we don't need a 0. Well, the rules don't change. We're going to say, well, we're going to think about what do we multiply x squared by to get 2x to the fourth, and that's 2x squared. So 2x squared times x squared, that's 2x to the fourth. The leading terms match, so when we subtract, this will go to 0. But then we just keep multiplying. We use the distributive property. So we have minus 4x to the third, and then we have plus 14x squared. In long division, we always subtract. We get 0 here. We get 0 on this one also. 13 minus 14, that's negative x squared. And then we bring down the next two because we're matching three terms up. Well, what do we multiply times x squared to get negative x squared? That's negative 1. I was going to put x, but we want negative 1. So we need a 1 here. And we get negative x squared plus 2x minus 7. And now in long division, we always subtract. So 3 minus 2 is x. Negative 11 minus negative 7 or plus 7 is going to be minus 4. So the answer is 2x squared minus 1, and then plus x minus 4 over x squared minus 2x plus 7. Synthetic division, divide using synthetic division. We can use synthetic division when we're dividing by a linear polynomial. So we want to put negative 2 in the box, negative 2 in a box off to the side. And then the coefficients, and we have to include any zeros if there are missing powers, and we're missing an x to the third power. So we have 2 for the x to the fourth. We have 0 for x to the third, negative 5 for x squared, 5 for the x, and then minus 2 out here on the end. Now we're going to draw a line, and we're going to leave some space underneath. Now everything is multiply and add, but we're going to bring the first one down. So 2 goes down. So now negative 2 times 2 is negative 4, so we multiply, and now we add. That's going to be negative 4. Multiply, that's 8. Add, we get 3. Multiply, negative 6. Add, and we get negative 1. Then we get 2 here, and the remainder is 0. Now, since the remainder is 0, x plus 2 is a factor of the original. Now, the answer is 2x to the third minus 4x squared plus 3x minus 1. So this is the constant. Then this is the x squared, and this is the x to the third. Let's take this polynomial divided by 2x minus 3. Now what goes into the box is what makes this 0, and what makes this 0 is 3 halves. So we're going to put 3 halves in the box. We have 10, negative 13, 5, and negative 14. 3, 2, 1, 0. No zeros needed. Let's bring down the first one. Then we multiply. Half of 10 is 5. 5 times 3 is 15. Then we have 2. Well, half of 2 is 1. 1 times 3 is 3. Multiply. So we multiplied. Now we're going to add. That's 8. Half of 8 is 4. 4 times 3 is 12. And then when we add, we get negative 2. So 2x minus 3 is not a factor of this because the remainder is negative 2 and not 0. So now here's the constant. Here's the x squared. So we have 10x squared plus 2x plus 8, and then minus 2 over 2x minus 3. Use the factor theorem. Use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. So we're asked, is x minus 1 a factor of this polynomial? Well, let's plug 1 in the box. We have 4, 21, 25, negative 5, and 3. 4, 3, 2, 1, 0. No zeros needed. So let's leave some room. Bring the 4 down. Multiply. 4. Add. We have 25. Let's multiply. We have 25. We're going to add. That's 50. We have 50, and that's negative 45. Negative 45, and that's negative 42. So the remainder is negative 42. The remainder is not 0. X minus 1 is not a factor. What about negative 3? I'm guessing it probably is, but who knows? 4, 21, 25, negative 5, and 3. Let's bring the first one down. 4. We have negative 12. That's going to be 9. Multiply, that's negative 27. So we have negative 2. A negative 3 times the negative 2, that's negative 6. That's going to be positive 6, excuse me. That's going to be 1, and negative 3 times 1 is negative 3. So we get a remainder of 0. That means x plus 3 is a factor of the polynomial. Well, now we can write the original as x plus 3 times 4x to the third plus 9x squared minus 2x plus 1.